Hi everyone, welcome to ChipRide, and in this video we are going to see how to do a simple PCB design with a very good tool which is the DipTrace. And DipTrace, I'm going to show you how to use DipTrace first of all, and maybe in the future videos we'll go see how we can go with a single-sided PCB, double-sided PCB using SMDs and all those things. But in this video I'll just show you how to use the DipTrace tool first of all and make a simple single-sided PCB design. And you have to first download the freeware which is available at diptrace.com. You can see diptrace.com here, and under downloads we have the freeware version. You can download it, and the like if you want to go for multi-layer PCB design, still this software tool provides the feature, but for you have to buy the tool. So if you're going for a single-sided PCB design, it has some limited provisions where you can design your PCB very well and you can export it. And also it has 3D library. You can see here download 3D libraries, and some models are actually provided, and you can see visualize in the 3D like how your PCB will look like. So this is a very good tool, and you can use it. And let's see how to get started with this. So what you have to do is download and install the software. On once it when you are launching it, you will see this window which shows the schematic capture, the PCB layout, component editor and pattern editor. Schematic capture is the electronic capture, like from the paper physical circuit. We are going to capture that into a this like into a screen, and we'll be checking the electrical rules check, all those things, and then we'll export it to PCB layout. And PCB layout can also be used for the baseboard PCB designs directly if we are not going to design a circuit. And then component editor is like you can edit your own component by getting the data sheet of the particular component and its measurements, and then that can be edited. And then for that, similarly for the component, you can edit pattern, which is actually the pattern editor. So we are going to look into PCBs first. The first step is the schematic capture. So let's click on this. So you can see we have a blue color line here, which is actually actually pointing out the origin, and you have the grids behind with the dotted lines. And first of all, what we have to do is, if you don't have this origin, you can click on F1, so the function key F1, and you will get it. And basically you can see here we have the grid size, which we can access 6.25 mils to 12.5 mils, and then 300 mils, like that. So I'm just changing it to 300 mils. You can see the grids. So what is the difference? We'll see now. Before that, I will show you the basics. Like you have the components here, component library. So here in this component library we can see the basics: audio buses, list their patterns, net ports, capacitors, tantalum capacitors, all those things. So user components can be created, libraries will be there, and we have many provisions. And not only that, if you have to go with the general components, you can see here we have the capacitors. You can see its dimensions mentioned here, part numbers. So accordingly you can check the pattern for the particular PCB here. Here we can see that this particular component where it shows this line here, which is called the silk screen, and these are pads actually, where the is to say this is a through hole component, where we have the through hole components are like the component which has leads. So those leads like which can get into the hole. So the basic discrete components are actually through hole component which can get into the holes, like their leads will be inserted and you can solder it. So those components are called through hole components. Apart from that, we have SMD component which has surface mounted devices. So here we can have electrolytic capacitor pattern here. These are like tantalum capacitors, polycap, diode, LED, all those things. To make a simple circuit, what we can do is try to place this LED. So assume we are going to get this LED here. 1 minute, I'll select it properly. So we have LED like this. Sorry, not diodes. I'll take LEDs. So we have this LED 1, LED 2, LED 3, and LED 4. So I'm not designing any circuit here. I'm just showing you how to use this tool properly. So this is, you can see the grid, which is 6.25 mil. Now you can see I'm able to easily move the component here. Now let's make it to 300 mils. Now you can see will not be able to move the components properly. So according to your convenience, you can arrange this grid. So I prefer going with the 6.25 mils. And you can see these are the component symbol, and which has the number 1 and 2. Here if you place it, it shows D1, K1, so which is cathode and anode. It shows the leads properly, and whenever you place the components, you can see the labeling is there, D1, D2, D3, D4. So as per this physical circuit, you can match it like whichever component is going to be D1, D2, D3, R1, R2, R3, similarly like that. And now what we can do is we can select this place wire, or if you want to get it from here, we have the objects. In object circuit, we can see place wires, place bus, and edit mode. To simply connect, we can have the place wire. So we can take this place wire and then click on this. You can see a plus symbol here. Click on the lead and then you can connect it, and you can see another red mark here. Once it appears, you can leave it. Now we can see the components are connected. Again, I'll do it for another LED here. Click on place wire. Now I have selected 1 and then I connect 2. So let's connect it like this. Finished. So I have properly connected the lead. So what we can do is to adjust it to make the circuit neat. You can just keep it like this. Now you can use the navigation keys here. Now to rotate the component, you can just click the component and press R on your keyboard, which helps you to rotate the component. And now the first step in PCB here is to go with the electrical rules check. So we have to go to the setup here. You can see we have rules to check, like pin type. We have many pin types, anode, so analog, digital kind of stuff. And then it shows the basic not connected pin superimposing, nets with single pin, and short circuits. So we have VCC and ground, then it shows a short circuit. So if you just leave the connections simply on floating, then those kind of errors also comes in. So what you have to do is check everything and then click run ERC. It says no error. So if you can set up and then click here and press F9 in the keyboard, or just click here which says no error. Once you don't have any error, what you can do is, so and one more thing I just wanted to show you, always try to place it in the center or your quadrant, one of the quadrant here. So this origin helps you to keep the circuit in the center, so you don't miss the circuit when you're zooming out and zooming in. And then now what we are going to do is we can move this to the layout version. So I'm going to see, this is not a circuit, I'm just showing you how to design it. And then once you have this electrical rule checks passed, then you can click file, then convert to PCB. Now it automatically invokes the PCB layout window. So you can keep the use this basic schematic rules and then click OK. And now you can see here I don't have the origin, so I'm going to click and I'm getting F1 and I'm getting the origin here. Similarly, you can keep this as 6.25 mil and you can keep it as mils here. And in view, sometimes if you're getting white screens, all those things, sometimes it might be background might be white. What you can do is basically you keep the graphics mode as OpenGL, and then you can click on colors, and here you can select the background, all those things. Here you can see black background, all those things you can change here. So I have the default background, so I'm leaving it here. And what you have to do is next, what is the thing is, you can see here we have the layout of the to say the pattern of LED, and here these lines are actually the rat lines, which shows the connections between the leads, actually, to say. Okay, so once you place the traces, these rat lines will vanish. So what we will have to do is just show you something. You can see this red mark on this another red mark on the pad of the area, different area, shows that there is a connection existing, and this you can see again. And to be very clear, I'll rotate the components. You can see the rat lines very clearly. Okay, then next thing is we'll have to we can just pull this components pattern here somewhere, keep it here. And one more thing is, what you have to do is, in view you can place this units to be mils or inches or mm, depending upon how you are going to draw the dimension of the board, the mechanical layer. So what we can do is, I'll place it as mils. So here in object we have the same thing here, dimension, but still I'll go here and for the first time I'll show you here. It says board points. Here in board points you can simply create a rectangular board. Instead of drawing, you can just create a rectangular board, which you can say it here as some 300 mils, a square PCB, 300 mils, let's say. Create a circular board, create a round rectangular board. So let's make it a rectangular board here simply. So we can see here the outline of the mechanical layer. So we'll not be able to place the component here. So what we have to do is, I can delete it. Objects, board points, create rectangular board. Just make 1000 cross 1000. Now you can see the board outline here, which is created in the quadrant. Now what you have to do is, in PCB, you have to be very sure that this placement is very important. To say, when you are placing the components, you should be very sure to place the components in such a way that it follows symmetry. It is arranged in different like if you have a similar components like resistors and capacitors. Even you can so look into the PCBs where we have the resistors, diodes all aligned properly. So this should follow the vertical or the horizontal symmetry properly. So what we have to do is, now for example, I'm placing this LED. Now you can see I'm able to rotate it. Now I can place this LED like this, one more LED like this, one more like this, one more like this. So it is like, just if you keep things arranged properly, what happens is you can easily draw the traces. Now you can see the traces here. It's like rat lines are crisscrossed. You can make the rotate the LEDs in such a way that though these lines are not crossed. So now you can see my lines, the rat lines are actually proper properly placed. Now what we are going to do is here, this says this is top and this is bottom. So usually plot on the top side we place the component, on the bottom side we'll place the traces. So now we can clearly see the traces here. So we'll simply draw a trace here. So what we have to do is, you can see you have different options: place rack lines, place pad, place static wire, and then place copper pole, all those things. But for traces you will have to go to root. So manual routing, you can check, select this add traces, and select this and draw a simple trace. So connect the rack lines which are connected together and the pads which helps you, which shows as red here. So now on the top side we can see the component side. On the bottom side this is trace. This is actually a simple single-sided PCB. So you can just move the traces like this, and even the trace width, you can click change the trace width to custom. I'll make it 30 mils. Here also I can make it 30 mils. For placing the traces you will have to follow the current carrying capacity and the traces. So like how much is needed here, like the thickness of the copper and then the width of the trace, so that it can carry. For LEDs you might not require that much. So in case of power tracks you have to go for 40 mils by default. So we have current carrying capacity versus trace width, which you will have to find. You can get it in Google also. Based on that you can fix the trace, so trace width. Now once you are done with this, what we can do is just click on 3D. You can see there is I have already added the library, and here you have 4 LEDs placed, simply the 3D library, and this is the component side where the LEDs are placed. Now we will rotate and see the bottom side where we have the traces. So this is single-sided PCB design, single-sided PCB design. So what you have to do is you can simply take a power supply circuit or something like that. Maybe I will show you in the next video on how to design a simple power supply circuit with proper connectors, all those things, and then we can see the actual PCB code. So this tool is very nice tool, very good tool. Other than like we have a free version here, and not only that we have this options of going with single-sided and double-sided PCB using both through hole and assembly components. So thanks to the makers of this tool, you can learn PCB using this tool. Now I'm going to close. So as for now, in this video I just wanted to show you how this tool is very good to do a PCB design, and I have been using it I went with this tool first, and there are industrial tools, already, the cadence, and we have many other good tools. So what you have to do is for simple PCB designs you can actually go with this tool, and you can see the access for libraries, components, everything is there. Here you can easily go through. You have connectors, everything is listed here in the component library, or we can even create our own components. You can see we have many processors, even the processors, you can see processor components, RL78, everything here. So the latest version they are adding more libraries, so you have many options here. So you can simply try this, then we can go with the next video where we'll see more good circuits, how to place components, how to effectively design a PCB, and then how to export it for the manufacturer. So this is what I wanted to show you in this video. Thank you. Thanks a lot.